Let me explain the change of base rule. Change of base rule looks like this. If I want to type this in my calculator, I can't because I can't write that 7 in there. But if I write log of 49 divided by log of 7, it will give me the right answer. So everybody type in log of 49 divided by log 7. See how it's 2? Where if you just typed in log of 49, you'd be thinking 10 to the what power equals 49? Because remember, it's in base 10. All right, let's try doing this one. Has anybody already figured out 28? 2 to the power of what? 16. 4. Everybody write down 4 is the right answer for that one. 2 to the power of 4 is 16. And then what I want you to try right now is type in log 16 divided by log 2. Change of base rule always works. So technically you could put all of these in your calculator if you wanted to and just have them tell you what it is. There's another way you can do it. If you hit math, I believe. I haven't done this in a long time. Probably that one, log base. Yep, so you pick, okay, so if you go to math and you go down the column and you pick the one that says log base, you can actually type in what the base would be. So if we want to do this one, log base 7 of 49, go math. This is the first year I've been able to use this. What was it, log base 7 of 49? 2. Also, you could do log 49 divided by log 7. And if you're wondering, why is this the first year you've done this, Ms. Nussbaum? It's because this is the first year I've had all of my calculators are TI-84s, because TI-83s could not do this. So I always had to use the change of base rule on the other ones. Okay, does everybody feel like they could probably do this back side of this worksheet? Okay, we're going to flip to the other side. You're going to have 2 worksheets due for me on Friday. One is this one, and the other is the other one that I will teach you how on a video to do tomorrow. This one is how to solve log equations. This probably will come up a lot on college entrance exams, ACTs, etc. Let me switch papers so you don't have to look through the background. All right, let's start with number 4. What's the base on this?
10.
Everybody write in 10. If it doesn't have a base, you assume that it's 10. Base 10 for both of them. What's the opposite of a logarithm? Exponential, which means I'm going to put a base 10 down on either side, and that will cancel out. This right now is like 10 to, like this is all in the power, and that actually cancels out both of these. So I can just say 5x minus 7 equals 3x minus 1, which I hope you can solve. Get 3. It's pretty easy to get rid of a logarithm when it's the same thing on both sides. Like, for example, let's go down to number 10. Log base 14 on both sides. How do I get rid of a log base 14? Put down a base 14 on both sides. Base 14, cancel, cancel. Now we've got 6v minus 1 equals v squared minus 17. How do I solve this when there's a v squared involved? Quadratic formula, yeah. So now I'm going to subtract 6v and add 1 to get it to the other side. That's 0 equals v squared minus 6v, and then what? Negative 17 plus 1, negative 16?
8 and negative 2.
8 and negative 2? Did you use your formula?
Yeah.
So if you used your program for this right now, what would you put in for A? 1 and B? -6 and C is -16. Are we feeling fine about these so far? Okay, now let's talk about what happens when it doesn't have a log on both sides. Let's try number 5. Okay, what do you think we should do to get B by itself right now?
Calculate the log.
No. There's a B in here. So we're trying to solve for B. It's like we're trying to take it apart, right? So what should we take apart first? How do we move stuff away from the left side on number 5? Come on, guys, stop whispering. Say what you're thinking.
Move the 1.
Move the 1 first. Can you guys see that? You'd probably subtract 1 first. Let's subtract 1. Get that out of the way. Now I've got a log base 5 of -9b equals 3. I can't touch that -9b until I get rid of my log base 5. How do I get rid of a log base 5?
5.
Put down a base 5 on both sides. On this side, it cancels out, and I have just -9b. But on the other side, it's 5 to the third power.
125.
5 to the third power is 125. Now what?
Solve for B.
Divide by -9? 13.9-ish. You guys get that? Negative? We'll just round to the nearest tenth. How you feeling about this? Okay, let's try right now. Let's try one more with me, and then I'm going to have you work with your partner to the end of the hour. Let's try number 8. All right, what should we do first? I'm going to add 5 first. I don't want to, I do want to get in here. You're thinking about the crossing it out by putting a 3 down, right? And I want to do that after I get rid of this 5. So now I've got log base 3 of x plus 1 equals 0. And then what?
Turn the 0 into 1. Right?
Okay, you are right, but you are explaining it in the most confusing way
Oh,
possible.
sorry. I thought you went further. Base 3.
A base 3.
No, that.
Now 3 to the 0 power is 1.
Sorry, I thought you went further.
Gustavo's like, cross out the 0, just put a 1. And everybody's like, what's happening? X plus 1 equals 1. And then?
Solve for x.
Subtract 1, x equals 0. How you feeling about these log equations?
How is that? We never.
Anything to the 0 power is 1.
What if there's a different log number on the other side, like 2 different log numbers?
When that happens, which is something that will not happen in this course and will not happen on your ACTs or your college entrance exams, but what they do then is it's like finding a common denominator where you make them have the same base. So like if I had 2 and 4, I would change it into, like if it was base 2 on this side and base 4 on this side, I would change the 4 into a base 2 and then add a square up there, because that would make it still 4. Does that make sense?
Yeah. What about math leagues? Will that happen on math leagues?
No. These might,
Yeah.
but no. Changing that, we do, in Math League, we do deal a lot with, one of them is being able to change bases. So going from base 10 to base 7 or something, which we'll discuss. All right, I'm going to leave you with your partner right now. Why don't you work on this together?